Okay, we are going to add on a little bit to that last video and talk a little more about phase shift and sinusoidal curve fitting and actually do one of the problems on your homework. First of all, on number one, if we just look at the equation, we know that this is y equals a sine bx minus h. Okay? Well, h is our horizontal shift. Our phase shift is h over b. So this gets more into electricity and things like that. So I didn't really focus on so much phase shift as I did horizontal shift. But on this worksheet, we're going to do phase shift, which is just nothing more than this h divided by this b. So your amplitude obviously is 4. Your period is 2 pi divided by b, which is 2, so it'd be 2 pi over 2, which is just pi. And then your phase shift is the horizontal shift, pi, divided by b, which is 2. So that would be your phase shift. Okay? So that's how you would do number 1, 2, 3, 4, 5, and 6. On 7, all we're going to do is write these equations in this format. Now notice I use phi instead of h. I don't know why I should have used h. I did not, and I apologize. But the phi is basically h over 2, or h over b, sorry. So this phase shift will have to fill in as h right there. And if you get this, don't worry about it if you didn't understand that. This would just be simply y equals 2 sine, then the period's pi, so b would be 2 pi over pi, which would be 2. So it would be 2 sine 2x minus 1. Since b is 2, phi is h over 2, which is phase shift. Well, h is 1, b is 2, so h over b, 1 is h, b is 2, so it works out perfect. So it's just minus 1. Okay? All right, now let's do an actual problem, though, as far as it relates to the last part of this phase curve fitting for sinusoidal problems, real-world sinusoidal problems. So this is the average monthly temperature in Juneau, Alaska. I believe this was about 5 years ago, was the average temperatures. And what we're going to do is we're supposed to use our calculator to draw a scatter diagram. So what I'm going to do is I'm going to make this a little bit smaller if I can. And I know the average monthly temperatures. And then I'm going to come over here on our calculator and I'm going to go stat edit, and I'm going to go and fill in, clear enter, sorry, forgot to hit enter, and then clear enter those. And then list 1 is going to be my x's, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the months, January through December. List 2 then are the temperatures. Okay, so our temperatures, 24.2, oops, sorry, 24.2 and 28.4 and 32.7, 39.7, 47. So in May, the average temperature is 47 in Juneau, Alaska. In June, it's 53. I could get used to this. July, 56. August, 55. September. October. November. And December. Okay. Now, we're supposed to create a scatter plot. The first thing we want to do is make sure our mode is in radians. So I'm going to go over here and click radians, mode radian. Then I'm going to go zoom 9 for zoom stat. And it did not work. What What's the deal here? Oh, I didn't turn my stat plots on. So I got to go to second y equals. See that? And I want a scatter plot. And list 1 is my X list. List 2 is my Y list. This all works. If I have a TI-83, an old one, I just go here. Let me redo this again. Oh, sorry, Y equals, and I just go up and I turn the plot 1 on. I just go up there and press enter. Okay, now zoom 9, and there's my graph. Whoa, that looks like a sine curve or part of a sine curve. And so what we're going to do by hand, I'm going to have you figure out your amplitude, your period, all that stuff that was on the previous video. So by hand, draw a sinusoidal function of the form. So I shouldn't say really draw, find it. What's A? Well, amplitude is the largest minus the smallest divided by 2. Your K, your vertical shift, is your largest plus the smallest divided by 2. Your B is pi over 6 because it's 2 pi over 12 months. So your B is 2 pi over 12. So now you got to find H using algebra. And when you work that out, just follow the other video and you'll be able to do that and figure out what H is. Now, we're going to do it by our calculator too. So on C, using your calculator, enter this function you found by hand. Is it close? Well, whenever we get our by hand, we're going to type it in. Okay? Then we're going to actually find the regression, the actual sinusoidal regression. And here's how we're going to do that on this calculator. You're going to go to Stat, Calculate, and you're going to go to Sine Regression, letter C. Now, iterations, don't worry about that. We'll just keep whatever it's set at. X list is list 1. At Y list is list 2. Don't worry about the period. We're going to store regression equation by going to, look at my cursor, vars, yvars, function, enter, y1, and then we're going to go to calculate. There is the equation. The amplitude's about 15.6. The B is about 0.52. The C is minus 2.09. And the D, the actual K, our vertical shift, is 40.37 degrees, 40.38 degrees. Now, let me do this again for those of you that have a TI-83. You're going to go to Stat Edit, or Stat Calc, sorry. You're going to go up to letter C, Sine Regression. Then you are going to get a menu or a line right here, and it's going to say SINREG. Then you're going to go to second L1, comma, second 2, which is L2, comma, and then you're going to go to vars like we did on this step when we went down here to store regression equation. Now I'm not going to tell you how close this is to the one we got, but there it is graphed, and it's pretty darn close. The calculator can get it almost exact through those points. So you can easily see that this data is well represented by the sine regression. Okay, that's it. If you have questions, make sure you ask me whenever you see me again or on the Zoom call.